associated with industry. So if you just look at the greater metropolitan region for PM10, you get about 90,000 tons per year in terms of the overall emission. For Newcastle, it's about 4.8 tons per year. But non-urban sources, which do not include the cities of Sydney, Newcastle, and Wollongong, have about 65 to 66 tons per year. And of those, the New South Wales inventory suggests that about 70% are from human or anthropogenic sources. I'm not allowed to say man-made anymore. That's considered to be too sexist. PM 2.5, you've got about 32 tons per year. Newcastle's got about 32,000 tons per year. Newcastle's got about 2,000 tons per year. And the non-urban sources are 17, quite a large percentage, and about 73–75% are considered to be from human activities. If you drill down a little further, PM10 in the total non-urban area, now we're in the industrial section of the inventory, about 83.5% of the total of the overall non-industrial or non-urban area is from industry, and about 93% of this comes from human sources. And for PM 2.5, it's about 13,000 tons, and about 78% of this comes from human sources. And finally, we get down to more specifics. If we look at PM10 from an industrial, non-urban sources, about 76% in the inventory comes from mining from coal, about 10% from electric power generation from coal, and other land-based extracted is about 3.5%. Remember, PM10 is broadly, strongly influenced by that coarse particle fraction, which has grinding and digging and other things like that, but non-burning processes. For PM 2.5, industrial non-urban sources, now we're talking about burning processes. Mining for coal is about 50%, electric power is about 20%, and industrial vehicles and equipment is about 10%. So you still have coal, but other sources being quite important as a mix in terms of the greater metropolitan region inventory for the particle matters PM10 and PM2.5. Now let's go back, let's go down again in scale or focus on what we have in Hunter. And the Environment website has two networks. Now we have the Upper Hunter network, which many of you are familiar with, and that data is on this website. You have to do a little fiddling to get into it, but it's still there. You've got 14 monitoring stations in the Upper Hunter measuring hourly PM10. You've got 3 monitoring stations measuring hourly PM2.5 from Musselbrook, Campbellwell, and Singleton. And that's just an example of the information, part of the information that comes up on the website when you put the map up. And you have wind as well, wind direction and wind speed. This would be, for this particular time, what would be on the map on the website that shows you what we call the real-time or immediate data. Now the important thing, one of the things that we need to remember a little bit about this data is that these data are not quality controlled. These are raw data that are simply put on the website, specifically directly from the instruments measurements. So if we're going to do research and other things like that associated with this data, there needs to be a bit of quality control to ensure that we have reasonably good, high-quality data set. But they are good for information for the public. Now what I did, just an example, just to illustrate a little bit about potential, what you can do with a website. Please ignore the blue line. The blue line is a glitch. You got it in by mistake. But I took one day, I took September 13th for Campbellwell, where you have measurements of both PM10 and PM2.5, and I defined the green line as the PM2.5, the fine particles, and then I subtracted that from the PM10 to calculate the coarse fraction. And this is simply an idea of what happens over time when you go over a 24-hour period using 1 hour data. In the middle of the day, or mainly the middle of the day, from about 4 or 5 in the morning until about 9 or so at night, you can see that the coarse fraction of the PM10, the grinding and other sources of non-burning is dominant. And you can see that we're not defining sources in terms of this calculation, but you probably might estimate and say, okay, depending on what the wind is going on, this could be a mining emission in terms of dominant for this particular day during the day. But look at what happens later at night from about 2200 on and going into the early morning. Well, we're going back early morning on this particular day. That structure of these data changes considerably. And in fact, the fine particles, the PM2.5, become more dominant in terms of the overall picture. That suggests the burning process is taking over and not a grinding or surface soil or anything other kind of process. Why? We're not sure. This requires further research. One possibility is wood smoke burning from residential houses. We don't know enough about that yet. So from an academic point of view, in terms of the research, I'm salivating because I want to find out more information. So now the EPA issues a series of alerts, and basically these alerts are when rolling hourly averages of PM10 for 24 hours is greater than 50 micrograms per cubic meter. It is simply a health warning based simply on the measured data. Alerts can occur at any time of the day. And those of you who have them, or probably many of you have a setup where you can get an alert through your mobile phones. There's no indication of the cause of the source. It may be caused by high emissions of either fine or coarse particles, or both, PM both. And it may be caused by data error. I've seen one example where one of the days had a huge spike for 1 hour in terms of concentration of particles that didn't make any sense whatsoever in terms of what was really going on, and it could have been an instrument glitch. But again, we don't know that until we have a chance to research it. So the details regarding the sources and require data analysis, quality control, and research. So this is a map of the Upper Hunter network. This happens to be, thanks to Craig for this, July 2012 to July 2013 overall average of PM10 and PM2.5 for the Upper Hunter network, which is the big square rectangular box at the top. And we're beginning to build, or the EPA is beginning to build a network for the Lower Hunter. So in the Lower Hunter, we've got 3 stations, and, well, actually 4. The EPA monitors in the Lower Hunter have been there for a while. They were established in 1996 when the first attempts at national pollution inventory work and sources and emissions was set up. So these are at Beresfield, Wallsend, and Newcastle. And if you want to see one and you like to swim, go to Wallsend swimming pool, have a nice swim, and then look off to the east in the corner, and you'll see a station right there. Okay? So again, you go back to the website, which I mentioned earlier for the Upper Hunter, but now you click on the Lower Hunter website information. Again, the current PM data from these is online, but for these stations, unless it's changed very recently, the wind information is not online. And my recommendation immediately to the EPA is to put the wind information online as well, to match the Upper Hunter network. There's a 4th station at Stockton, and it's operated through Orica, and I'll get to that in a little bit. The idea is eventually to add the Stockton site to the EPA network and establish new stations at Mayfield, really at Cold River. There's a current station in Mayfield that's been there a very long time, but it's no longer suitable. So the idea, I think, is to move it over to where CSIRO buildings are at Cold River and put it on the top of the hill there, which would be an excellent site. Then Carrington, which is very interesting because that's an inner suburb under the lee of the harbor activities, and perhaps Rutherford a little bit later on. There are other sources of information available in the Newcastle area, including a number of industrial dust deposition and high volume air sampler sites. So as a result, and at some urging, the EPA established a series, a commission monthly reports for the Lower Hunter air quality information. These are done are on the website, at the EPA website under a different section. And each report, each monthly report, has its own little signature. So if you wanted to have May, for example, you'd have to go to May 13 instead of April 13. Or you wanted to have June, you'd have to have June 13, etc. The reports started in March this year, and it's an initial 6-month contract, but I certainly do hope that they will extend it, because I find personally these reports are very, very useful. They're well written, and they're easily accessible and understandable by the interested public. The reports are prepared by Todarowski Air Sciences, and the other thing I hope is that these Lower Hunter concepts in terms of these reports might also extend to the Upper Hunter, so that you will have a monthly summary of the overall picture of air quality in the Upper Hunter, a monthly summary of the overall air quality picture in the Lower Hunter. So these reports include things like the sites themselves, where they are located and why, the air quality criteria, particles and other pollutants, monitoring data results, and analysis of elevated pollution levels, basically getting more into the why things are occurring, the meteorology associated with all of this. So as I said, I find this very, very useful in terms of a summary, and I strongly encourage you all to have a good look at these reports on a regular basis when they're available. Now, Craig, Jeff showed a couple of pie charts for the overall GMR, Greater Metropolitan Region, and I've got a couple for Newcastle, just as examples. This is PM10. Again, this is on the website, the EPA website. As I mentioned, the EPA website is a very, very useful source of lots of information. So this gives you an idea of very recent concentration, sources, percentage of sources in the Newcastle area. So industrial is 47%. Never mind. Industrial is 47%. The next largest is domestic, associated potentially with wood heaters, 16 or 17%. Off-road mobile is 19%. And then the smaller ones are commercial and biogenic and on-road mobile and so forth. You can also do this, obviously, for PM 2.5, but to use that, you have to use ANSTO data. This is the Australian Nuclear Science and Technology Association. They've been measuring PM10 and PM 2.5 at Mayfield for about almost 20 years. So it's quite a long and very useful detailed data set. And they can do things like through chemistry of the particles, the samples are sent back to Lucas Heights, and through neutron activation analysis, they can establish some basic inorganic chemistry structures of the particles, and from that, through statistical analysis, calculate potential source categories. Now, the problem is that if you go to ANSTO, you want to get into this information and where the sites are located and then the reports. You seem to have to go to this very, very long website. And if you're anything like me, with fat fingers on the keyboard, I would have to have typed this in about 5 times to get it right. So it might be easier, therefore, by the way, the measurements from the ANSTO data, and then the network is on Wednesdays, which is a weekday, and Sundays, which is a weekend day, for comparison purposes. So it might be easier to go into the New South Wales EPA Newcastle Community Consultative Committee in the Environment website area, which is also on the EPA. So there you are, okay? And you can now have a look from the ANSTO data of the percentage source contribution to PM 2.5. There's a report that extends from 1998 to 2009, so about 11 years or 10 years, that gives you an idea of PM 2.5 categories of sources within the Newcastle region. So you have automobiles, secondary sulfates is the two most important sources, then smoke, which I have to assume also includes wood smoke from residential houses, sea salt, industry, and soil. So rather quite a different picture in certain terms of percentages from overall PM10. So the coarse fraction of PM10, which isn't done, I don't have information on that, but probably should be done. It would be very interesting to see what the percentage sources contribution to the coarse fraction are overall, then you get the overall structure. How am I doing here? Okay. The Stockton data set from the Stockton site, again I mentioned the Stockton, this is the website for the Stockton data set up in quite a similar way to the system and with a similar information from the Upper Hinton network. This includes daily and hourly current information plus weekly and monthly graphs. There's also historical information, although the Stockton site has not been running, it's been running for several months, maybe a bit more than a year, but doesn't have a huge list of history. It measures both PM10 and PM 2.5 in terms of particles, plus wind speed and wind direction, and there's ANSTO availability chemistry from the site because there's an ANSTO site availability from there, but that's not on the website. So you can download this in tables and graphs. So if you do the graph, for example, this is just recently in September, you get these kinds of concentrations over time, and it looks rather spectacular.